How did server deployment evolve with containerization? Have you ever wondered how server deployment changed over the years, especially with the rise of containerization? Let's take a closer look at this fascinating evolution. In the past, deploying applications on servers was often a complicated task. Each application needed specific dependencies and configurations, leading to the common issue of works on my machine but not in production. Traditional virtual machines, which have been around since the 1960s, allowed multiple operating systems to run on a single physical machine. However, these virtual machines were heavy on resources and took longer to start because each one included a full guest operating system. The journey toward containerization began with the introduction of the troop system call in Unix back in 1979. This innovation allowed processes to be isolated by changing their root directory, creating a sandbox-like environment. While this improved security and separation, it was limited in its capabilities. Fast forward to the 2000s, and container technology began to advance with features in Linux like control groups and namespaces. Control groups, added to the Linux kernel in 2008, allowed for resource allocation and limitation for groups of processes. Meanwhile, namespaces provided isolation for system resources such as network and user identifiers. These advancements enabled multiple isolated Linux environments to run on a single host without the overhead of full virtual machines. The real game changer arrived in 2013 with the releases of Docker. Docker made containerization practical and accessible for developers. It allowed applications to be packaged with their dependencies into containers that could run consistently across different environments, whether on laptops, servers, or cloud platforms. Since containers share the host operating system kernel, they are lightweight and start much faster than virtual machines. This portability transformed deployment pipelines, reducing compatibility issues and speeding up testing and releases cycles. As more developers adopted containers, managing numerous containers manually became a challenge. This led to the emergence of orchestration platforms like Kubernetes, originally developed by Google. Kubernetes automated the deployment, scaling, and management of containerized applications across clusters of servers. It introduced features such as automatic scaling, self-healing, and load balancing, making it easier to run complex microservices architectures reliably at scale. From the perspective of backend development, containerization simplified server-side logic deployment. It encapsulated application programming interfaces, databases, and services within isolated, reproducible environments. This isolation helped avoid conflicts between dependencies and made continuous integration and continuous deployment workflows smoother. Developers could focus more on writing back-end functionality without the worry of environment inconsistencies. In summary, server deployment has evolved from heavy, resource-intensive virtual machines to lightweight, portable containers that share the host operating system kernel. Containerization introduced process and resource isolation, improved deployment consistency, and enabled scalable orchestration. This transformation has made back-end development and deployment more straightforward, efficient, and reliable, supporting modern architectures like microservices and cloud-native applications.